Oh no, okay. All right, so example 8.0, you can tuck this one in before example 8.1. We're going to find and determine the nature of any stationary points for y equals x cubed and y equals x cubed minus 17x squared on 2 plus 10x plus 5. All right, so we'll do A first. If it says to find and determine the nature of any stationary points, how do we find the stationary point first? We find the derivative and set the derivative equal to 0. So I'm going to write in there that that's what that actually means. Whoops, I picked the right pen. Find f dash of x equal to 0. So find the derivative, set it equal to 0. That's what is meant when it says find the stationary points. So for A, we've got y equals x cubed. So y dash is simply going to be 3x squared. We let y dash equal 0. Therefore, 3x squared equals 0. And we realize then that x must be 0 as well. So that tells us that we have a stationary point at x equals 0. You right? Find f dash of x equals 0. That's what find a stationary point means. All right. We need to know the coordinates. So when x equals 0, y equals, and we put it back into our original equation, which is x cubed. 0 cubed is 0. So therefore we have a stationary point at 0, 0. But remember, all stationary points must be classified as either a minimum, a maximum, or a horizontal point of inflection. And I'm going to show you two different ways to do that. So firstly, we'll classify by a sign diagram. And the sign diagram is of f dash of x. So f dash of x in this case is 3x squared. We know that there is a 0 at x equals 0. So our sign diagram is going to look like this. 3x squared is a positive quadratic, so it's going to be shaped like this, which means it's positive and positive. Bearing in mind that this quadratic simply touches the x-axis once at x equals 0. So underneath the sign diagram, we draw our little lines showing the shape of the graph at that point. Positive, 0, positive. That shape tells us that this is a horizontal point of inflection. So therefore, horizontal point of inflection at 0, 0, and that's enough. The second way we're going to do it is we're going to classify it. This is just showing you, you don't have to do both. You can pick one or the other, and they work better in different scenarios. But I'm going to show you how to classify via a conditional test. You would use a conditional test when you've got a really awkward function. Obviously, x cubed is a fairly simple function. I'm just showing you how to do the conditional test. You draw up a little table with x, f dash of x, and slope on the left, and we need 3 columns. In the middle, we put our x value of interest where our stationary point is. That's our stationary point, x equals 0. We know when x equals 0 that the derivative also equals 0. That's the whole point of the stationary point, and that means the slope at that point is horizontal. From there, we simply pick simple values that are on either side of our stationary point. Pick really simple values like -1 and +1. Our derivative, f dash of x, is 3x squared. So when x equals -1, -1 squared is +1 times 3 is 3. So our slope at that point the value is greater than 0, so our slope is positive. We do the same for x equals 1. 1 squared is 1 times 3 is 3, so the slope is also positive. So we've confirmed, therefore, that it's a horizontal point of inflection at 0, 0. So a couple of things. It's very straightforward to find the x-coordinate of the horizontal point or of any stationary point, but you must go then and find the y-coordinate to state it as a coordinate pair, and you must classify it to to maximum, minimum, or points of inflection.